Hey everyone. So today what we are talking about is naming compounds, okay? This is just a rough overview of everything. So what in chemistry took us maybe 10 days, we're going to do in 1 day, okay? So we should be down with naming. So I have broken it down into 3 sections. So every time you look at a compound, you should be seeing if it is ionic, if it is covalent, or if it is acid, okay? Acids are easy to tell because if it begins with an H, we're going to start naming acids. Metal, non-metal, okay? Ionic is metal, non-metal. Covalent is non-metal, non-metal. Well, how do we know that? We look at our periodic table, right? I talked about this a little bit yesterday, okay? Remember that stair step on the periodic table? Everything to the right of that stair step is a non-metal. Okay, everything to the left of that stair step is a metal, with the exception of hydrogen. Hydrogen is a non-metal. I wrote an NN for hydrogen there. So, ionic, we're looking at something on the left side with something on the right side. Covalent, we're looking at two things on the right side. So I'm going to give an example of each of these real quick before I erase this whole thing that I wrote out, okay? So ionic, metal and a non-metal. An example of this, the most basic ionic bond, is NaCl, okay? It is a compound that does not have a transition metal in it. So all I do is I say the first element, which is sodium, and the second element is chlorine, but instead of saying chlorine, I keep the prefix of chlor, and I just add "ide" to the end. So sodium chloride. All right, so this is ionic, and that sodium is not a transition metal, so we're over on this side. Now let's do an ionic bond that is a transition metal. Remember, transition metals are in that little rectangle right in the middle. Okay, so those transition metals are a little rectangle right in the middle. So let's go for another ionic bond such as FeCl3. I look at this, I see that this is a metal, this is a non-metal. Okay, so it's in my ionic tree, but is there a transition metal in it? I look at iron, that's a transition metal. Okay, so again, how we name this is I'm going to say iron. That chlorine is still going to be chloride, but here's the difference. Okay, transition metals can have varying charges, so we have to state what the charge on that iron is with one of these Roman numerals. Okay, how do we know the charge on iron? We just look at its partner. Okay, chlorine, if you look at it, it's in the halogens. Chlorine usually has a charge of -1. Okay, well, how many chlorines are there? 3. So all together, all those chlorines have a charge of -3. So my iron better have a charge of +3. So I would put a Roman numeral 3 in there. Okay? So ionic, metal, non-metal, we look to see if it is a transition metal or not. If it doesn't, we just name it. So things like barium oxide, sodium chloride, lithium sulfide, okay, things like that. Transition metal, then we have to give a Roman numeral, okay, things like manganese 2 oxide, iron 2 chloride, things of that nature. That's ionic. Let's move on to covalent. Covalent is non-metal, non-metal. So those are two things on the right of the stair step, or maybe a hydrogen over on the far other side. We have to list prefixes for those ones, and that just tells us how many of each element there is in the compound. So I'll go right here. So say I have something like, let's go C2H4, okay? I look at this, I see both are non-metals, right? Hydrogen's a non-metal, carbon's a non-metal. So I have to use the prefixes to tell me how many of each one there are. So carbon, there's 2 carbons, so it is dicarbon, okay? And then hydrogen, there's 4 of them, so it's not tetrahydrogen. It's like our ionic one, it's tetrahydride. We keep that prefix and add "ide" to the end. So it's dicarbon, dicarbon tetrahydride. Okay, so dicarbon tetrahydride. So we're using prefixes for covalent bonds. Let's do another one. Let's do P6O4. Okay, I look at this, I see that phosphorus and oxygen are both nonmetals. So I go ahead and name these. 6 is hex. So hex phosphorus sounds weird. We want to say hexa phosphorus. And then 4 is tetra, so it's tetroxide, not tetraoxide, tetroxide. Okay, if the element begins with a, what are those called, vowels, okay, you usually don't want to put tetraoxide. That looks weird, putting an A and an O, so you just make tetroxide. All right, so hexaphosphorus tetroxide. One thing about covalent that can be tricky is something in the common example of CO2. Okay, CO2 you know is carbon dioxide. We don't say monocarbon dioxide, we just say carbon dioxide. So if you see a covalent compound and the first element is by itself, you don't have to say mono, okay? It's just assumed. So you just say the element. So carbon dioxide, say we did, okay, SO3, that'd be sulfur trioxide, okay, things of that nature. And then let's get to our last one, which is acids, okay? Acids all begin with H. We're talking things like HCl, we're talking things like HSO3, okay, HNO3. Okay, these are all acids. And then they get divided into two branches. If they have two atoms, like HCl here, it just has H and Cl, and then ones with 2+ atoms, which are things like H2SO3 and HNO3. Okay, these have more than 2 atoms. This one has hydrogen, sulfurs, and oxygens. This one has hydrogen, nitrogen, and oxygen. Okay, let's focus on those 2-atom ones. So 2-atom ones like HCl, okay, all you're doing is you're going to call it hydroblankic acid, where in that blank goes the prefix of the atom attached to the hydrogen. So chlorine, so it would be hydrochloric acid. So this would be hydrochloric acid. Okay, there's only a set amount of these with 2 atoms. You have things like HF, HI, and HBr. Hydrofluoric acid, hydroiodic acid, hydrobromic acid. Okay, fluorine, fluoric, iodine, iodic, bromine, bromic. All right, an exception to my rule of 2 atoms is one like HCN. Okay, that's cyanide, so that's hydrocyanic acid. And one more is H2S, that is hydrosulfuric acid. Okay, so those are 2 exceptions to kind of the 2+ atom rule, but that's it. All right, and now this next one, if we have something with 2+ atoms, like HNO3, okay, it's got 2+ atoms. So now what we're focusing on is the attached polyatomic ion, which you guys need to remember, okay, like NO3, which is nitrate, okay, nitrate, that nitrate ends with an 8, right, so I will change 8 to ic, so it was originally nitrate, so I am going to change it to nitric acid, so this is just nitric acid. No hydro. Hydro is only with 2 atoms. So 2+ atoms, you just say nitric acid. Okay. Let's look at H2SO3. Okay. Again, it's got more than 2 atoms, so I'm looking at that. That is sulfite. Okay. So again, sulfite. It'll become sulfus acid. Sulfurous acid is a better way to say it. I've heard it both ways, sulfurous acid and sulfurous acid. I think it just depends, but I think the more common one is sulfurous acid. Okay? Let's look at one more acid one. Let's go with H3PO4, okay? So again, this has more than 2 atoms and it begins with an H. So I look at that polyatomic ion, which is phosphate. Okay, remember 8 to ic, I to us. Phosphate becomes phosphic. So this is going to be phosphic acid or phosphoric acid. Again, it's one of those things where they're both right, but phosphoric is just more common. Okay? Make sure you know those polyatomic ions, right? Because we might have a situation where we get something like NaOH. Okay? That looks weird. That's more than 3 atoms, but it's not an acid because it doesn't begin with H. It's not covalent because sodium is a metal. Okay? So it's got to be ionic. No transition metal involved. So then how do we name this normally? Well, with polyatomic ions, you just state the name. So this is sodium. This is polyatomic hydroxide. So this is just simply named sodium hydroxide. That's a nice thing about polyatomic ions. And you usually know you have a polyatomic ion in there when you have more than 3 atoms in your compound here. Okay? So let's erase all this and let's do a few examples. Let me actually steal some from my handy dandy notebook. Let's get some good examples here on how to name things. So, hope you all are having a great day. All right, let's get to it. Let's go with all right, so I look at this guy, CaSO4. I look at this as definitely not an acid. Okay, let's look at what types of atoms these are. This is a metal, okay? If I know calcium's a metal because it's on the left side of the stair step, I already know I'm dealing with ionic. Is calcium a transition metal? No, it's not a transition metal. Okay, it's already, got a +2 charge, it's fixed, it is an alkaline earth metal, so we're just naming this guy. So this is just calcium sulfate. Okay, calcium and the polyatomic ion. Next one, HF. Okay, I look at this. Automatically right off the bat, I see it starts with an H, so it's definitely an acid. Does it have 2 or 2 plus atoms? It only has 2 atoms, so this is hydrofluoric acid. Don't quote me on the spelling now, okay? Hydrofluoric acid. Let's do another one. Here's a tricky one, okay? Here's a tricky one. I look at this, give it a shout if you want, pause this, but look at this. I see I got a metal and a non-metal, okay? So it's definitely ionic. Is cobalt a transition metal? Yes, it is a transition metal, okay? So it's going to be cobalt something, and oxygen becomes oxide, okay? Well, let's think about this. I got to figure out the charge on cobalt, so I got to look at the partner, okay? Oxygen, if I look on my periodic table, it's in the chalcogens or the -2 column, so oxygen has a -2 charge. But how many oxygens do I have? 3. So 3 times -2 is a total charge of -6. -6, okay? So that means all these cobalts have to have +6, but I don't want the total charge of all the cobalts. I just want the charge on a singular cobalt atom. Okay, so yeah, it's +6 for all these cobalts, but I have 2 of them, right? So how are those 2 cobalts going to split that +6 charge? They're each going to get a +3, okay? A +3 charge. So it's not 6 that goes in here, it is 3, okay? Make sure that you are just giving the charge on the individual atom. All right, let's do one more example. Let's go with HNO2. Okay, begins with a H. It's an acid, more than 2 atoms. So I look at this guy, and he ends up being nitrite. Remember, ate to ick, ike to us. So nitrite becomes nitrous. And don't forget to put acid, nitrous acid. All right. So hopefully that's good enough for naming. So going from formula like HNO2 to name like nitrous acid. Now let's go backwards. Let's go from name to formula. So say I have something, let's go strontium bromide. Okay, so we could kind of use our little chart of ionic, covalent, and acids to help us with this as well. Okay, it's not an acid because there's no acid stated here, so it's not one of those. It's not covalent because I don't see any mono, dis, tris, tetras, or anything like that, so it's got to be ionic, okay? And here's the thing. Is it a transition metal? No, there's not Roman numerals in there, so it's just a straight up ionic compound. So what I do is when I see something like this, like strontium, I go ahead and I put its symbol and I put its charge, okay? Strontium is in the second column, so it's got a 2+ charge. It's an alkaline earth metal. And then I do bromine, which is Br. Bromide comes from bromine, and bromine is a halogen, so it's got a -1 charge, okay? And then what you have to do here is just make sure that the charges are balanced, right? All of our compounds are going to be neutral, okay? There are some polyatomic ions that aren't neutralized, but they bond with other cations. So here, we got to make it neutral. So in order to cancel out that 2+ charge, I'm going to need 2 bromines at -1. So now my formula is SrBr2. SrBr2. Okay? Let's do another one. Let's go with magnesium oxide. Okay? I'm looking at this guy. It's not an acid. It's not covalent. It's ionic, and it's not a transition metal. Okay, so these guys have fixed charges on the periodic table. Magnesium has a 2+ charge. Oxygen has a 2- charge. And look, those are already neutralized, right? 2+ will cancel out that 2-, so it's just MgO. Okay, MgO. Let's go with I look at this guy. Okay. First thing I notice right off the bat are di and hex. Those look like a bunch of prefixes, okay, that I've seen before. So this is covalent. Disulfur, so that means I have 2 sulfurs. Hexoxide, so that means I have 6 oxygens. The nice thing with covalent, they don't transfer electrons, they share them, so you don't have to worry about charges. Okay, covalent, it just tells you. That's the nice thing about covalent. All right, let's keep going. Let's go with manganese 2 sulfate. Okay. I look at this and I see that Roman numeral and I automatically think this is ionic with a transition metal. So manganese is Mn. Sulfate, right? If it ended in sulfide, then it's just sulfur, right? Chloride, bromide, sulfide, oxide, those are all elements on the periodic table, but this one ends in 8. If you see anything that ends in 8 or ite, that's a polyatomic ion. Okay, so sulfate is SO4 with a 2 minus charge. And manganese, what's the charge on it? 2 plus. A good reminder that Roman numeral is not how many manganeses there are, that's the charge on the manganese, okay? Make sure you remember that. So 2 plus 2 minus, they're canceled out, so this guy is just MnSO4. So manganese 2 sulfate is just MnSO4. Again, charge, not how many manganeses there are, just the charge. Let's do another one. Go with think of it. Give me a second. Phosphoric acid. Okay, phosphoric acid. Again, it's acid, so we're definitely dealing with something that starts with an H here. But is it going to be one of those 2 atom ones or one of those 3 atom ones? I look at this. It doesn't say hydro. It's not hydrophosphoric acid. Okay, it's just phosphoric acid. So it's definitely not a 2 atom one. So this means it's got to be one of those 3 plus atom ones with a polyatomic ion in there. So remember, 8 to ik, I to us. It's the same deal backwards. So 8 to ik. So that means we're going ik to 8 now. Okay, so phosphoric must have came from phosphate. Well, what is phosphate? It's PO4 3 negative, and I better have as many H's in front there to neutralize that phosphate. So again, it's acid, it's got to begin with H, so we're going to have 3 H's because hydrogen has a +1 charge. Okay, let's go with one more and then I'm done. Let's go with titanium 2 hydroxide. Okay, hydroxide. Now you might see hydroxide and you say that ends with I. That must be an element on the periodic table. There's no element called hydroxine. Okay, there's hydrogen and there's oxide. Okay, but there's no hydroxine. Hydroxide is actually one of our polyatomic ions, and you should know that if you've been with chemistry for a while. But if not, okay, get used to it. You're gonna be seeing hydroxide a lot. Okay, so hydroxide, it's called hydroxide because it's got a hydrogen and an oxygen, and it's got a -1 charge. Okay, titanium. Okay, transition metal. You see that Roman numeral there? It's got Ti and it's got 2 plus charge. Okay, and now let's make sure we balance this guy out and that we're making it neutral. I'm going to need an extra hydroxide in there to make sure I neutralize that out. So it's just titanium 2 hydroxides. Okay, so that's it for naming. Let's get some practice with this. Make sure you're studying those polyatomic ions because you can't have that on the test. Make sure that you got your periodic table all labeled out with the charges so that those stick in your brain better, okay? And then have yourself a great day.